Okay, so we're going to talk about AI and its impact, and this is based on a forthcoming book that we have called Power and Prediction, which builds on our previous work on AI. So there is no shortage of hype and excitement around AI. We expect adoption to surge, and despite that, there's a lot of confusion out there about what we're really talking about when we're talking about AI. If we read the press or watch movies, we think when people are talking about AI, there's like an optimistic thing, which is the droids from Star Wars. So Star Wars, not an optimistic galaxy, but the droids from Star Wars are quite optimistic, right? They are machines that can do just about everything we can do, but they do, some things better than us. One that's really important is that they listen to humans, and that's what makes Star Wars not necessarily an optimistic universe, but an optimistic artificial intelligence universe. The rest of science fiction, of course, is filled with these machines that can do everything we can do, but they don't listen to us. And that's how we get, the robots from the Matrix or Skynet from Terminator or whatever else. It's very important. So I don't think this idea of a truly artificial general intelligence is crazy. I used to, but after listening to a couple debates, I think, okay, it's possible. But if you talk to the experts, it's 20 to 50 years away. It has been 20 to 50 years away since the very first AI conference at Dartmouth College in 1956. This is not the technology we're talking about today. The technology we're talking about today is something a little more mundane. It's prediction technology. Using information you have to generate information you don't have. That's what you just heard about from David, right? Prediction technology, computational statistics has gotten much better, faster, cheaper. Okay. It's less exciting if we say that. So we're going to go with AI, but just recognize that when we're talking about AI and the potential of AI, what we're really talking about is computational stats has gotten much better, faster, cheaper. And that was, we can represent that. We're economists, me and my co-authors, and so we can represent that as a drop in the cost. Prediction has gotten better, faster, cheaper. Prediction gets better, faster, cheaper. Econ 101 tells you that we're going to use more prediction. Demand curve slope downward. Demand curve slope downward, so okay, prediction's cheap. We're going to see more and more and more prediction. Started to show up around 2012. We really saw this, what seemed to be a change in the trajectory around 2018, and that led to our book that came out in 2018, Prediction Machines. And so the hype kept building, and we were very excited about what was about to come. Jeff Hinton, one of the developers, sometimes known as the godfather of deep learning and AI, said in 2016, if you work as a radiologist, you're like the coyote, you're already over the edge of the cliff, and you haven't looked down. We should stop training radiologists now because in 5 years, 2021, AI is going to do better than humans. Daniel Kahneman, this last year, said clearly AI is going to win. All that he was curious about was how we humans are going to adjust to this new world. And yet, if you look at the data, there's a recent, the Census Annual Business Survey, AI adoption in manufacturing, under 5%. AI adoption in retail, under 5%. AI adoption in healthcare, under 5%. We see, okay, there's apparently a revolution happening. It's not showing up in the data. And so when you look at McKinsey, McKinsey did this recent survey, said, okay, thousands of companies, lots of them said they have an AI strategy. Lots of them saying they're using AI for all sorts of exciting things. Okay, have you had a significant financial impact from AI? 89% say no. Okay. There is an 11%. The 11% are getting it. They're companies like Amazon that have used AI to improve their recommendation engines. Recommendation is a hard problem. We actually saw a version of an Amazon recommendation engine yesterday, right? It advances through AI in a recommendation engine, and look, recommendation is prediction. We're trying to predict what a customer might want. And we've been trying to do that. Retailers have been trying to do that for hundreds, if not thousands of years. And so Amazon's allowing us, AI is allowing Amazon to do that better, faster, cheaper than the old system. But for the rest of us, for the 89%, we're in the between times. The between times are this era where we see the potential of the technology. We know what's coming, but it hasn't come yet. We're still waiting for the transformation. And so when you see the hype around AI, we see all these people saying AI is the new electricity. The potential is extraordinary. Look, there's electricity everywhere. AI is the new electricity. It's going to transform the economy. But when these people use that analogy, I think they don't know the history of electricity. Okay? And here's a little bit about the history of electricity. The commercial potential of electricity was obvious in the 1870s. We saw, Edison saw, others saw, electricity was going to transform the way we lived. Electric lights, electric motors, it was going to be what it is today. That was clear. But electricity didn't hit half of factories and half of households until the 1920s. It showed up in the productivity stats 50 years after the commercial potential was recognized. The between times were really long. Why? What happened?
Distribution problem.
Well, it was more than distribution. We had to invent that. Exactly. We had to know that distribution was a thing. Right? So it's not just that, oh, we had to figure out how to distribute electricity. We needed to invent the idea that we needed to distribute electricity. And so in the old, think about factories. A steam engine factory looked like this. Okay? So you can see everything's connected on top to a central motor. And the central motor powered the factory. And the factory was organized around this central motor. So wherever the steam engine was, you put your most energy-intensive machines near the engine so that less energy was lost in the distance. And you put your less energy-intensive machines farther from the steam engine. That meant you tried to build your factory around the steam engine in 3 dimensions, not just 2. So you had things above and below the engine to be close to the engine. You had these. The engine was always on. And so if you wanted to turn off a machine, you had to unhook it, which was both time-consuming and a little bit dangerous. And so what happened in the 1870s and 1880s and 1890s? Said, hey, electricity, this is cheap energy. Let's take out our steam engine and put an electric motor. That sounded awesome. That sounded great. Cheaper power. We save 5, 10, 15% on energy. And the factories operated just the same way. And so electricity, it made a difference, but it was pretty incremental. It wasn't until decades later we figured out how to design factories. And what we learned was, well, electricity, yes, it's cheap energy, but it's also distributed energy. So we could run our factories totally differently. We could build them so that the inputs go in one end and the outputs go out the other, and we just have conveyor belts that's Henry Ford, driving things through the factory from one end to the other. The workflow could be organized based on inputs to outputs as opposed to where the energy needs were greatest. That meant we didn't need to build our factories up. We could build them in on huge, cheap land, way out in the suburbs. And it transformed the way industry works, and that's when we saw the productivity boost. It took a long time to figure that out. A lot of things had to be invented. Right? We had to figure out, how does a factory get organized? We had to figure out, how do we distribute electricity? We had to figure out, well, you know what? Where's cheap electricity? Niagara Falls. Okay, Niagara Falls. We had to figure out how to generate energy from Niagara Falls. All this co-invention happened. And that's the essence of general purpose technologies. When we think about general purpose technologies, the steam engine, electricity, the internet, and now it seems like AI, the between times are long. The between times are long because we have to invent all sorts of things. We have to invent things in the producing industry. We have to figure out how to generate electricity more effectively. AC versus DC. We have to figure out how to distribute electricity. And then downstream, we invent light bulbs, we invent consumer electronics, and we invent new ways of organizing our factories. Now, that story seems to be playing out with AI. Erpin Jolson, Daniel Rock, and Chad Syverson have this paper saying, what we saw with electricity, what we saw with the computers that were clearly valuable in the 1960s, and by the 1980s we still hadn't figured out how to get a productivity boost from them, we are now seeing again with AI. And what they emphasized is, in order to really take advantage of the technology, the economy needs to undergo some kind of restructuring. And so the question for prediction technology is what kind of restructuring? How do we make the between times, rather than lasting 50 years, last 5 to 10? We know the history, so we can proactively try to co-invent, redesign the way we work, and take advantage of technological change. What we mean by that is we're going to have AI system-level solutions. The AI here is not going to be a point solution where we figure out, OK, here's the workflow. Let's figure out a human doing a prediction. Let's take out that human and put it in a machine. That's, by definition, going to be incremental. Instead, with better, faster, cheaper prediction, what can we do totally differently? How do we need to redesign the systems? Where are there sort of rules where we do the same thing over and over and over again because we don't know the state of the world? And if we knew the state of the world, if we had a good prediction, we could do things differently. So we'll start with a pretty topical one. So AI did not save us from COVID-19. OK. I don't think that'll shock anybody here. But maybe it will shock you to say that I think it could have. Lots of caveats, of course. Well, you can look at those in the footnotes if you're really interested. But there was potential here. And what do I mean by that? 2 years and a bit ago was a declaration of a global pandemic. And everyone in the world said, wow, this is a serious health problem. Let's start listening to the health people. And the health people made all sorts of decisions on how we should respond to the pandemic. Okay. But Joshua, my co-author, who is able to write words at an extraordinary pace, wrote a book that came out in May 2020 saying, no, it's not a health problem. It's only a health problem for, at the time, the 1 in 5,000 people who had COVID. For the other 4,999, it was an information problem. If we knew who had COVID, or in particular, if we knew who was infectious, we just keep those people home. And the rest of us can go about their business. Lockdowns, all these tools we built to respond to the pandemic weren't about the health problem, they were about the information problem. And if we could solve the information problem, then it wouldn't have been a big deal. For a short period of time, we'd isolate the infectious people, and then, the pandemic would peter out. Turns out, well, it was a pretty hard information problem to solve. But that wasn't it. That wasn't only it. There were lots of people who were building tools to try to solve the information problem. Some of them, once you're already in hospital, X-rays with AI, this is the one that worked best, but it wasn't that useful. There were people trying to do, OK, let's cough into my phone. And based on my cough, you can predict whether somebody has COVID or not. OK? It didn't work as well as we might like. There were all sorts of other prediction tools that came out there, right? There was PCR tests, right? These tests that, that could happen at point of care. There were dogs that were trying to sniff out COVID. I don't know if you remember that story. We had wastewater. We had thermal cameras. There were all these tools. These tools were designed to predict who had COVID. They were designed to solve the information problem, not the health problem. One tool turned out to be better than all the others. And this is rapid testing, antigen testing. Wasn't perfect, but it was pretty good at solving the information problem. Okay. False positives are really rare. And false negatives, depending on who you talk to and how you define false, is somewhere between 50 and 99%. I mean that, are you trying to catch people who have COVID in their system, or are you trying to catch infectious people? If you're trying to catch infectious people, they're extraordinarily good. If you're just trying to catch people who might have COVID in their system, they're not nearly as good. Okay. So antigen tests, rapid tests, they were out there. They were out there, clearly available, commercially available by September 2020. Problem solved. The information problem was largely solved. So COVID should have gone away. But it didn't. It didn't because we didn't know. We had the prediction tool. Not an AI here, but a prediction tool. We had the prediction tool, but we didn't know how to do the state contingent decision making. We didn't have the system built around it. We tried to build one. So we developed a large-scale system for antigen testing in Canadian workplaces. In the end, we got about 2,000 Canadian workplaces into our system. We, for better or worse, you may not like this, we kept the Canadian oil patch open as people were testing before going into work. But making this happen was hard. The technology, the prediction problem, was effectively solved in September 2020. But it turned out in September 2020, it was illegal to use antigen tests in Canada. Okay? It was illegal to import them into Canada. We got a whole bunch shipped, and they were stuck on Halifax Pier. Okay? It was, we had to do things like, so there was all sorts of regulatory issues. And then the workplaces had to figure it out. Well, no one wants to test if you're not going to pay them. So they had to change decisions around sick pay and all sorts of other things. In the oil patch, they had to figure out, what do you do with people who have COVID? Because they're way out in Fort McMurray, which is not near anything or really, anywhere that you can just sort of isolate people in an easy way. And so all these other decisions, we had to design a system to deal with it. We made some progress, but and scaled in some sort of narrow sense. But we didn't quite get there to our ambition to have antigen tests, the prediction, solve the information problem at scale around the world. And so system change, even the prediction is often the easy part. The message of the COVID story is, hey, it was hard to recognize this as a prediction problem. Like there's an information problem and prediction would be a solution. Once we recognize that though, you'd think it was done. The prediction was there, it was on hand. But that turned out to be the easy part. It was then 2 years of work to build a whole system that could take advantage of the information. We didn't know how to do that. And so we think through in industry by industry after the between times, as we're taking advantage of prediction technology, in this case, software-based AI prediction technology, how do we think through the new factory based on better, faster, cheaper prediction relative to the old? What does that new factory look like? So here's two airports. The airport on the left is Seoul Incheon Airport. It is a multi-billion-dollar airport, often rated as the best airport in the world. The airport on the right is a shed. And you look at these two airports and you think, well, which airport would I rather be in? And since I'm asking you, you guys have already figured it out, that you want to be in the shed, right? That's a private jet airport. Airports are only built like that because we're stuck at airports. No one wants to spend time at airports. The mission of Seoul's Incheon Airport is to ensure smooth air transportation. Those multi-billion dollars don't help you ensure smooth air transportation. A little bit of them do. But we'd much rather not have to spend any time at the airport at all. And if we had a better prediction, we wouldn't have to. If we knew how long it would take to get to the airport and through security, we could transform, to redesign our industry to solve that problem, to actually do what we're supposed to do. Now, doing that is going to cause a lot of pain. Those billions of dollars that went into Incheon Airport, well, that's thousands of people's jobs. That's the business model of the airport as it stands, which is they make money from people spending, being stuck at the airport and having nothing better to do than shop. All this is part of that transformation. I said, here's Amazon, right? Amazon's recommendations, they're awesome. They're something like for every 20 products they recommend to you, you want and will buy one of them. It's incredible, right? They have hundreds of millions of products in their catalog, and they're right 1 of every 20 times. That's an incredible AI. But it's the same kind of recommendation engine they had in 1995, right? And they're in the same business they really were in 1995. There's been some changes, but they're a catalog company. They're a good catalog company. but they're a catalog company. At least this is part of it, is they're a catalog company. And so we could transform, we can reimagine what that industry could do. Well, if their predictions got good enough, well, why recommend anything to you at all? Why not just ship things to your door? And if they're instead of you shop and they ship it to you, but they ship it to your door, you don't have to take it. It just has to be worth it for the company to build a system for returns, right? If they get a big enough share of your wallet, Well, yeah, okay, they'll have a truck come by and pick up the stuff you don't want. They'll figure it out. The prediction has to be good enough, and that can be transformative. Hasn't happened yet at Amazon, but if you think about what Stitch Fix does, in many ways that's exactly what they do. And if you listen to the Stitch Fix CEO, that is exactly her vision. So when we're thinking through navigating the between times and coming out the other side, the things to think through are, first, when you hear AI, don't think the matrix. Think better, faster, cheaper prediction. Okay. But then say, OK, that can be transformative. But in many ways, that's the easy part. The hard part is rethinking what your system will look like, what your industry looks like to better serve your customers if you can fill in that missing information. Thank you. Time for questions.